All right, we're going to move on to lesson 5.3. We're going to start today with a warm up going back to 5.1. So look at the polyhedron at the right. How many vertices are there? Remember, vertices are the corners. So 1, 2, 3, 4, 5. There are 6 vertices. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And then how many faces are there? So the faces are going to be 1, 2. So the 2 triangles. And then the 3 rectangles that go around the sides. So 1 down the front, 1 underneath, and then 1 in the back. So 2 triangles and 3 rectangles, that's 5. Verify this using Euler's formula, which is F plus V equals E plus 2. So that's 5 plus 6, which is 11, which is the same as edges plus 2. And that works out. Sticking with that formula, if one of them is missing, we can find it if we have the other two. So F plus 8 equals 12 plus 2. So faces is 6. What if the edges are missing? That would be faces plus vertices equals edges plus 2. Which is 23 equals E plus 2. Subtract 2. E equals 21. What if our vertices are missing? So that's 10 plus V equals 18 plus 2. So 10 plus V equals 20. That means V equals 10. If a rectangular prism has a diagonal of D, so D equals 25, a width of 11, a length of 14, what is the height? So that's 25 squared equals 14 squared plus 11 squared plus h squared. Remember, it doesn't matter the order of these three. So 625 equals 196 plus 121 plus h squared. Subtract the 317 to the other side. Which is 308. And to solve for h, we take the square root of both sides. H equals 17.5. If we were to round that up, we could say about 18. All right, so this is based off what we did yesterday. Shade in the shape's base. Identify the base's area formula, then find the volume. So I'm going to stick with the bottom being the base, and the other base is going to be on the top. So it's a rectangle. That means B equals length times width. The height is 8. So the volume is 12 times 3 times 8, which is 36 times 8, which is 288. Capital B times H. Next one. Now, the base in this one is not the bottom. If it was this bottom rectangle, there is no top rectangle to mimic it on the top. This fell over. Here's the face that has an opposite, parallel, and congruent base, or face. So we have two bases there. So it's a triangle. So this is lowercase b times lowercase h divided by 2. The height, so the distance between them, if it was standing up on that triangle, would be 20. So remember, the base and height of a triangle have to make a right angle. So 6 times 5. That's capital B. And h is 20. So V equals 15 times 20, which is 300. Number 8. There's the base. There's the other base. So here we have a octagon. N-gon is good enough for us. So that's A times P divided by 2. The height is 13. So little a is 2. The perimeter, we have 8 fours. So that's B times H. So B is 32. Times 3, because these 2's cancel out. So nothing touches that blue 32. Blue 32. 96. All right, one small thing is going to change for us today. Today we are going to go from a prism, so a rectangular prism, to a pyramid. And remember, the big difference is that other base disappears, all the faces, all the walls collapse into a singular point. Same thing here. The top circle disappears and the curved wall falls into a singular point. So we can't use the idea of stacking this rectangle on top of itself until we reach the top. Because as we go from the bottom to the top, that rectangle in here, if I look at this base, if I move up a little bit, it's going to get smaller and smaller and smaller. So I'm not stacking the same rectangle on top of itself anymore. And if we were in class together, we would do more of a formalized proof of it to show that. But there is a standard comparison when we take a pyramid or a cone, which is a curved pyramid, and compare it to basically its parent figure, a rectangular prism or a cylinder. And it is smaller, but how much smaller? It is 1/3 the size. So B times H, and now we're just going to divide it by 3. Let me use the colors from yesterday. We're just going to divide it by 3. It's 1/3 the volume. So 3 of these can fit inside of here. 3 of these would fit inside of here. So same thing as yesterday, same thing as the warm-up, but now at the very end, we have one more step. We're just going to divide that by 3. We're still going to identify the base. We're still going to identify the height. Now the height is inside. It's straight up and down and it's perpendicular. So volume equals B times H divided by 3. B is 15 times 12. The height is 20. And then we divide that all by 3. So 15 times 12, hit enter, times 20. It gives me 3,600 divided by 3, gives me 1,200 cubic meters. So the base is a circle. Here comes my formula. Capital B is pi r squared, and r is 13 here. The height is 8. And we're going to divide that all by 3. So just do everything in the numerator first. Follow your order of operations. I'm going to do 13 squared first, times that by 8, times that by pi. Hit enter, divide by 3. I get 1415.8. If we were to round that up, we would say about 1416 cubic inches. So this blue part is the only thing different today. It's basically take what we did yesterday and divide it by 3. All right, here's our base. And notice what they give us here. They didn't give us a side length. They gave us 8 centimeters squared. They already gave us the value of B. So volume equals base times height divided by 3. So volume equals 8 times height, which is 18, divided by 3. which is 48. Notice where that height is. It's because the right angle, I can't say the height's inside of here. We'd have to walk out here and stand underneath this point, and that's where it would be perpendicular. All right, number 4. I'm going to identify my base. I always do that first. So this is going to be 10 times 10. This is not the height. This is if we were to walk up this side. Remember, the height is inside. So in order to find that, it's part of a right triangle. So if I was to take out that right triangle so we can only focus on that. This is 13, this is H, and this is 5, because there's a property that we haven't talked about until now. That basically inside, that height comes down and it cuts everything in half. So since this is 10, this is 5 and 5. So h squared plus 5 squared equals 13 squared. We have a missing side of a right triangle, so we're going to call on the Pythagorean theorem. Square root of both sides. H equals 12. Zoom out, give you a good place to pause it right there. Let's look down here. We have a cone. Let's identify the base. It's a circle. So that means pi r, which is 5, because they're showing us all the way across this 10, pi r squared. They did give us the height this time, thank you. And divided by 3. And just some mental math here. I'm going to do 12 divided by 3 is 4. 5 squared is 25. 25 times that 4 is 100. Pi is 3.14 times 100. We move the decimal place over 2 places. That's about 314 cubic inches. All right, let's see where our base is. It's another circle. So pi r squared. We don't have r this time. What happened? And we're back. We don't have r this time. The height is 15. So pi r squared is the circle, times it by 15 is the height, divided by 3 because it's a cone and it's not a cylinder. But what is r? We know that r squared plus 15 squared equals 17 squared. And how did I know that? because we have a right triangle right here. So r squared plus 225 equals 249. I'm sorry, 289. I knew that didn't sound right. Minus the 225, we get 64, which is a nice perfect square, so r equals 8. So I can come back up here and grab the 8. So simplifying this all down, I have 15 divided by 3 is 5. 5 times 64 times pi is about 1,005 cubic meters. I'll zoom out, good place for you to pause and take a look at that. All right, we are not going to do this page. And that is it for lesson 5.3. Make sure you guys take a look at the homework, then do the exit ticket, or do the homework, then get in touch with me, then do the exit ticket. Just make sure you guys are handling and taking care of everything in the daily agenda. And